To all, I'm Sung Hwan from UNIMAP. Today I would like to present my study with title COVID-19 mRNA vaccine degradation prediction using machine learning algorithms under the supervisions of Dr. Azamimi binti Abdullah. Since 2020, COVID-19 disease induced by SARS-CoV-2 have infected more than 173 million populations, resulting in a mortality rates of more than 3.7 million till the end of last week. In this crisis, mRNA-typed vaccines are the most favorable due to its safety assurance, high efficacy, and low cost in manufacture. But this mRNA vaccine is pretty unstable and prone to degrade. Therefore, this study is proposed to focus on the development of models using three machine learning algorithms to predict the degradation rates of mRNA vaccines by implementing the Eterna datasets that comprise of 6034 RNA molecules. For the vaccine that may not kill or weaken viruses or antigens, mRNA vaccine is by injecting mRNA that sends an instruction to the ribosome to produce viral protein to be recognized by the body cells and learns to immune it. In our case, will be the S protein of SARS-CoV-2. It is worth notifying that these proteins are solitary, so they do not resemble the form of virus, hence prevent danger. But unfortunately, its instability has become the biggest stumbling block in implementation. Another condition has a great impact on degradation rate of mRNA vaccine as presented. To allow for the high stability mRNA vaccine to be developed, it would be better to be clear on the degradation rates and stability of the vaccines under different conditions to enable further measurements to be done. Therefore, this study is proposed. The three main objectives of this study includes to implement visualization techniques, data cleaning, and feature engineering, as well as to predict the degradation of mRNA vaccine with machine learning algorithms. Next, the methodology. Owing to the problem stated, in general there are 6 main stages, namely data extraction, exploratory data analysis, feature engineering, data pre-processing, multi-predictions, and performance evaluation. For this study, the bpps number for the host probability for each base of the RNA to be paired is extracted together with the train and test datasets. Simple linear approach is done to gain utmost insight into the datasets. It is fortunate that there exists no missing values in the dataset for each instances and features. A number of features in form of aggregated functions will be engineered from bpps datasets to process the raw data into a more presentable features that are compatible with the algorithms for modeling. However, as sequence length varies between instances in test datasets, the individual features which shows different distributions from the others are eliminated. On the other hand, the data is clean in a way that noisy instances are excluded from feeding into the algorithms for training. To modify non-numerical data types data into numerical, two label encoding methods are proposed as shown in tables by first splitting the arrays into single character that resulted the number of instances to increase drastically from thousands to hundred thousands, followed by machine learning algorithms for prediction with linear regression like gradient-based machines and random forests. Since this study is in regression-based instead of accuracy, prediction error is proposed with group mean square error as the performance matrix with formula as presented. This table shows the prediction error for all the 12 model deduced from linear regressions, LGBM and RF, resulted after evaluation with RMSE performance matrix. From the result obtained, we may deduce that LGBM-based model that trained with bpps features which utilize the first label encoded method is the best model amongst in this study datasets. It is worth notifying that although in this study, RF-based model's prediction result may not surpass the LGBM, but it is believed that the RF-based model that trained without additional bpps features with applaudable performance as highlighted in gold is worth being further cultivated since it coincides with the actual situation where precise and bulk of data is hard to be obtained. On the other hand, the anxious user could interact with the system, an interactive graphical user interface prediction tool which is designed in a way to reach a delightful visualization standard is orchestrated. So, this is a general overview of the prediction to develop with Jupyter and Viola. There is a hyperlink here too, where when users click on it, they will be taken to the web page where the datasets can be extracted. Let's get back to our GUI. This prediction tool thus permits users to explore all the 12 models desired by simply click on the buttons. The predicted result will be presented in a while. Users are allowed to compare the results of 4 models each with different training methods at the same time. Users are allowed to explore all the datasets obtained from the Eterna database platform. Under the dataset explorations, when users select the bpps selection button, they could have a great view too on the deduced aggregated functions distribution curve. So that's the graphical representation of data cleaning when clicked the Explore More button. To conclude, LGBM is not only more suitable than linear regression and RF, but it does surpass the prediction performance of LSTM, GRU, and GCM models proposed by Anka Singer, the one and only one study that overbuilt for the time being on this topic, proving LGBM-based model developed is an excellent choice to be implemented and further modified in the field of COVID-19 mRNA vaccine degradation prediction study. Lastly, this study is believed to have a great impact to the society. The most significant contribution is to support in the development of the final high-stability mRNA vaccine to control the COVID-19 pandemic from rampant, so thus medicine and bioinformatics fields. Thank you.